Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the questions based on the motion under gravity. Okay, so let's start the video and let's learn a number of questions asked in a NEET and JEE exam. Okay, so the first question is, a ball is thrown vertically downward with a velocity of 20 meter per second from the top of a tower. It hits the ground after some time with a velocity of 80 meter per second. The height of the tower is how much here? Okay, so remember that here let's take, this is the tower here, and let's take from the point A we are going to throw the ball. In which direction? Downward direction. They have given with how much velocity? 20 meter per second. Okay, so let's take it here. We are throwing downward with a velocity of 20 meter per second. Okay, and when it is going to hit the ground, now let's take, this is the ground. Ground is this point B, and when it is going to hit the ground, final velocity is V, and how much it is given here? You can see very well, 80 meter per second. V equal to 80 meter per second. Why we are writing everything is positive? Because remember that here I have taken sign convention, downward plus and upward minus. And this convention by default always I will use when the ball is going, whenever any object is going in downward direction, I will take downward positive. Why downward positive? Because all the arrows you can see in downward direction. Even you can tell gravity, gravity, acceleration, A equal to, we can write here plus G. All the arrows are downward, so only we have taken here downward positive. Okay, so if we use here the equation of motion, so see here, S, you know very well, U is given, V is given, and we want the height. Is it height of the tower? So S will use the formula here, V square equal to U square plus 2AS. Based upon our intelligence, we have to choose the equation of motion. And why we are using here the equation of motion? Because acceleration due to gravity near the surface of the planet is a constant. Like Earth means 9.8 meter per second square, and that is a constant value. That's why we are using equation of motion for motion under the gravity based questions. Okay, so let's say V square equal to U square plus 2AS. We are going to use this equation from A to B. A is the initial pointer and B is the final point here. Okay, so what is the final velocity? Plus 80 meter per second. Now plus 80, plus no need to write here, see here, 80 square is equal to initial velocity how much here? Plus 20, that means 20 square plus 2, gravity plus G. Is it plus G? And G value how much is given here? 10. And let's take here this height. This height. Let's take here this height is H. Now I have taken capital H. Let's take here for example capital H. Okay. So when you will simplify this, what this will come here? H will come here 80 square minus 20 square by 20. Is it? Now after that here, even you can use here the A square minus B square formula also, in bracket A plus B, in another bracket A minus B. So 80 plus 20, in one bracket 80 plus 20 means 100 into another bracket 80 minus 20, that means 60, and here by 20. Is it? Then what will happen that here? This 0 and this 0 cancel anyhow, and 2 3 how much here? 6. 100 into 3 how much here? 300 meter. That means the ball has thrown from how much height? 300 meters. So which option is correct here? The correct option is here. Option C is the answer. Na? Very basic question is there. Very basic question. Is it? Great. Now let's move to the next question here, asked in a NEET 2023 exam. Now sign convention in this kind of questions are very important. If the sign convention is not clear, then the answers will not come. Okay, and here you know very well, in straight line motion only two possible directions. Okay, maybe upward or downward, maybe forward or backward. So here we are not using vectors, we are just using plus and minus sign to indicate the direction. So see here the question. A horizontal bridge is built across a river. A student standing on the bridge throws a small ball upwards with a velocity 4 meter per second. The ball strikes the water surface after 4 seconds. The height of bridge above water surface is how much here? Okay, and these options are there. Is it, students? So let's take here water is there. No? This is the water. No, this is the water is there. No? This is the water. No? And this is the water surface. No? And here let's take here for example, just for the indication purpose here, this bridge is there. The bridge is going like this bridge is going. Okay, but okay, I have represented like this here, like this bridge is going here. You can write here, this is the bridge. Okay, now let's indicate here the things. So things are what? Again, see here, a student throws a ball upward with a velocity of 4 meters per second. Okay, so from here this student is standing now, he has thrown the ball upward he has thrown the ball now with velocity u now, and here sign convention I will use here. Let's take, I have taken upward plus downward minus, now throwing upward here, is it? So u how much here? 4 meters per second, that means u how much here? Plus 4. Now if you wish you can write here 4 meters per second also, not thrown upward. After that the ball strikes the water surface after 4 seconds. Now what will happen that here? Let's take for example, when the student has thrown the ball, let's take time is t equal to 0, is it? Now what will happen? The ball will go up. Now, then after that, following the same path, it will come down, is it? But when we are drawing the representation and all, we will not write the same like up and down. Here what will happen, that the diagram will become very complex. So just for the representation purpose, what we used to do here? We used to represent like this is a just representation, okay, just representation. And here what will happen that here? The ball will fall. Actually the ball will fall here only. It will go up and it will fall down. But just for the representation purpose, we are writing this. And how much time is this? The time is 4 seconds. How much time takes? T equal to 4 seconds. Is it? And the g value how much is given here? 10 meters per second square. So what I am going to do here, let's take here, anyhow, this bridge B, and let's take here I have taken water, W. Is it? No. So we have to find out here this distance. This one. Now let's take here, this is H again. Okay. H again. So we know U, we know time, and H is given. Then what we have to do? Let's see here, students. So which equation of motion is better? We are going to use the second equation of motion. What is this? As S equal to ut plus half at square. Okay, this equation we are using. Now, whenever we are using equation of motion, we need 2 points here. Let's take B is the initial point, bridge, water is the final point. Now, so B to W we are going to use this. Now let's take here this H, we are just writing here as H. Now, and when we are putting all other data in a proper unit, H also we will get in a very proper unit. Okay, so see here. Now students, U how much here? You can see 4. Time how much is given here? Here t equal to 0, here t equal to 4, that means time is also 4. Now plus half. A value how much? Plus or minus, you know, the gravity is acting in downward direction here, okay? So A will come here, G value how much is given here? So A will come here, G is 10, so A equal to minus 10 meters per second square. Why minus? Because downward is minus, okay? So half, A is coming minus 10, T anyhow 4 square, is it? So what this will come here, kindly see the students? 16 plus minus, and we can write here, 2 5s are 10 and 5 into 16, 80. So what is coming here? 16 minus 80. When you will simplify this, it will come here minus 64 meters. Now, as we know very well, this height of the bridge from water is 64 meters. But why minus is coming? Because see, H is downward. See the arrow? H is the displacement. No? So, initial to final point, downward is negative. That's why this minus is indicating the direction. What minus is indicating? The minus is indicating the direction. Okay. So anyhow, the height of the bridge from the water surface is how much here? 64 meters. Is it? The sign convention is very, very important. Is it? Great. Now students, let's move to the next question here. The question is, let's see here. Two bodies, A of mass 1 kg and B of mass 3 kg are dropped from heights of 16 meter and 25 meter respectively. The ratio of time taken by them to reach the ground is, that is called the time of descent. Now, so let's take here for example, this is ball A and this is ball B, is it? And how much heights are there? Let's take here, this height is the 16 meter and this height is 25 meter. Now, so how much time they are taking? Let's take here, in first situation time is Ta, in second situation time is Tb. So remember that here we should know the formula of the time of descent. In the absence of here, time of descent formula is given by square root of 2h by g. This formula we get by using the second equation of motion, okay? Because the objects are dropped, so u equal to 0 and here ub equal to also 0. Just use the second equation of motion, you will get this formula, because number of questions can be solved by directly using the formula, okay? So root 2h by g. Hence, we are going to use time of descent for A by time of descent for B is equal to, you can see very well, this time of descent is directly proportional to root h because 2 and g is constant, is it? That means what we can write here, see, is square root of height of A by height of B, is it? So height of A how much here? 16 meter. Similarly, height of B how much here? 25 meter, is it? So 16 by 25 is square root of 16 means 4, is square root of 25 means 5. So what answer is coming? 4 by 5. So which option is correct here? The correct option is your option A. And remember that here, students, in the absence of air, this time of descent is independent of the mass of the object. Even the mass is same, mass or different, what will happen? If in case two different masses even is dropped from the same height, they will take the same time. Where? In absence of air. If air is present, air resistance is there, then story will be different and it will be depending upon the mass. So what I am telling, in the absence of air, mass does not matter. Mass matters only in presence of air. Okay, students? Great. See, answer is 4 by 5. No? Great. Now let's see this question. The question is NEET 2005 question. A ball is thrown vertically upward. It has a speed of 10 meter per second when it has reached 1/2 of its maximum height. How high does the ball rise? Okay. So anyhow, this is the ground and initial velocity is not given. So let's take here. The ball is thrown with initial velocity u from point A. Now, and when it is reaching half of the maximum height, let's take somewhere here at point B. Okay. And how much here? This is the maximum height h. Okay. And when it is reaching, where, students? At half of the maximum height, that means h by 2. That time its velocity how much is given here? Let's see here. At this time its velocity, they are telling here 10 meter per second. Okay, 10 meter per second. 10 meter per second. Now this is the velocity. This v is indicating the velocity. Okay. Now after that here, when it will reach at the highest point, that means at point C, that time you know what will happen? The velocity will be 0 meter per second. And question used to come at the highest point, velocity is 0, but acceleration due to gravity will be there downward. V 0, but A is not 0 at the highest point. Question came. Okay. So now we will use here. Now time and all they have not mentioned all, and let's see here the sign convention and all. You can see all the arrows upward direction. So I am taking upward plus, downward minus. By default always like this. What is the value of A? You know gravity acts in which direction? Downward direction, is it? And downward is negative, g value is 10, so minus 10 meter per second square. Now, so let's use the equation of motion as v square equal to u square plus 2as. Now, and I am going to use the equation of motion from point B to C, because at point B velocity is known, at point C also velocity is known. Okay, this is h by 2. Then what you think? This how much here? H minus h by 2. Again how much here? H by 2. Is it? So again I am going to use here, C, students. Where to where? I am going to use from B to C. B is the initial point, C is the final point. Okay. So what will happen at here? Final point velocity how much here? 0. So 0 square is equal to u how much here? 10 plus 10 or minus 10? Upward plus 2 plus 10 only. Okay. So 10 square plus 2. A value how much here? You can see very well. Minus 10, gravity acting in downward direction here. Minus 10, and displacement B to C. Displacement how much here? H by 2. Then what will happen at here? You can see very well this 2 and this 2 is cancelled. Is it? That means we can write here 0 equal to 100 minus 10h. Is it? So what will be the h? H will come here. Just simplify this here. 100 by 10, and this will come here 10 meter. That means this total height, how much here? 10 meter. Which option is correct here? The correct option is coming here, option A. And anyhow, you can see this time it is coming plus, because upward in positive direction. Is it? Great. See, 10 meter. NEET 2005 question based on the sign convention. Is it? Great. Next one, let's see here. The question is asked in a JEE 2022 exam. Let's see here. A ball is thrown vertically upwards with a velocity of 19.6 meter per second from the top of a tower. The ball strikes the ground after 6 seconds. The height from the ground, what they are asking? the height from the ground up to which the ball can rise will be k by 5 meter. They are asking the value of k, is it? So let's take here, this is one tower, no? And from the top of a tower, the ball is thrown. No? The ball is thrown vertically upward from here. Now let's take here, and u how much is given here? Sign convention, let's take here upward plus and downward minus, is it? By default. So u value how much given here? We can see very well the 19.6 meter per second. So remember that here 19.6 meter per second positive, na? Because upward positive. And let's take here time how much here? Here the time is t equal to 0. After that what will happen? The ball will go up. It will follow the same path, but for the representation purpose we will draw like this, is it? And what is happening that here? When it is striking the ground, how much time it is taking? You can see 6 seconds. That means here we can tell here t equal to 6 seconds. No? So t equal to 0 starting and t equal to 6 second ending. We have to calculate the height from the ground. Now this height we want. This height. You are getting? Students, what we have to do? We have to find out this height. No? Let's take here h. So we should know very well how much time the ball has taken to go up. Then the rest of the time it will take to come down also, is it? So what will happen that here? Let's take here from here to here the time taken is t. No? Here 0, here let's take time taken is t. So what I'm going to do here, let's take this is point A and this is point B. Okay. So A to B, the ball is going in which direction? The ball is there, na? The ball is going in which direction? Upward direction. Okay. So when we will use the equation of motion from A to B, which equation? The time we have to calculate now, we have to use the second equation, and that is called here directly. I'm writing here the formula, the time of ascent. It is given by u by g. Time of ascent formula, remember that here, u by g in the absence of here. U how much here? 19.6. G value, it is mentioned in the question, 9.8. So 19.6 by 9.8, how much here? 2 seconds. Now that means the ball is taking how much time? The 2 seconds to go up. Okay, 2 seconds. So 0 to 2 seconds going up, then 2 to 6 seconds is coming down. That means how much time it is taking from point B to let's take point C. Anyhow, we can see very well 2 to 6 means 4 seconds, is it? So now what I will do here, I will use again equation of motion from B to C. Where to where? B to C. And which equation? S equal to ut plus half at square, is it? Now what will happen that here? Let's take here this height is h. No? Unknown, we don't know sign and all. Depending upon the other signs and all, we will get the sign of h. U value how much here? You know very well at the highest point. The value of u how much here? 0, is it? So 0 into t, 0 plus half. A value how much here? Remember that here, na? Downward direction, and downward is minus. So remember that here. A I will write here minus 9.8 meters per second square. So see here minus 9.8. Time how much here? Guess? 2 to 6. That means 4 seconds. Okay, 4 square. So when we are simplifying this, it will come here. See, minus 1 by 2 into 98 by 10 into 16, is it? So what we can do here, is it? So we can simplify this here, the students see. 2 8 just 16, 2 8 just 16, correct now? Then after that here again let's take here 2 4 just 10, 2 4 just 8 and 2 5 just 10. That means it is coming yes here 98 into 4 by 5, is it? 98 into 4 by 5. Now see here 98 into 4. This 4 8 ja 32, 2, 3, so 4 9 ja 36 plus 3, 39. So 392 by 5. What is coming here? This S is coming 392 by 5, and even if I write here with the properly, minus will be also there. What minus will indicate? The minus will indicate the direction, because downward is negative, so displacement in downward direction. But anyhow, we have to compare with the K by 5. No? So here K by 5 and here 392 by 5, only pure length we are seeing. So K value will be how much here? The K value will be here 392. Is it? See how much sign convention is important to solve the question. Is it? J 2022 question. Now let's see next one, students. So see here the question is J 2020 question is this conceptual. See, a ball is dropped from the top of a 100-meter high tower on a planet. In the last half second before hitting the ground, it covers a distance of 19 meters. Acceleration due to gravity near the surface of that planet is how much here? Okay, so let's see. this is point A now, and how much height is there? Ball is dropped, that means here velocity how much here? 0. Okay, and how much height is given here? You can see very well, the height is 100 meter. Okay, this height I can write here, this height is the 100 meter. Okay, and let's take it takes time t, is it? It takes time t. So let's take here time is t equal to 0, and let's take here time is t equal to t, is it? Now students, what will happen at here? Somewhere here at point B. Now let's take here, it is taking, how much time is given here? See, in the last half second, in the last how much time? Half second, is it? So this much, here to here it is taking how much time? Just a half second time is taking, is it? So remember that here, if this is the half second, that then just think from here t equal to 0, here how much time? T equal to t minus half. Getting t minus half, one more half second means reaching t. Okay, so I hope so you are getting very well here. The time is t, this time t, and time t, is it? And this much height how much here? 19 meter. Now data is very important. Without drawing a diagram we can't do it here. So 100 minus 19, it will come how much here? It will come here 81 meter. How much coming here? 81 meter. 100 minus 19, 81 meter, is it? So now I hope so this is very clear. A to C time taken is t, A to B time taken is t minus half, because B to C time is a half second. Okay, if this distance A to C is 100, A to B how much distance? 100 minus 19, that means 81 meter. And the sign convention we know very well here. You can see all the arrows downward direction. So anyhow I will take here downward positive, is it? And what we have to know? We have to calculate the value of the gravity. Now gravity value, G value. Okay, so first what I am going to do here, I am going to use the equation from A to let's take here B. Okay, so A to B, when I will use the equation, this equation, see here, S equal to ut plus half at square. Okay, then what will happen that here, students? Think S will become how much here? 81. No, A to B 81, is it? And anyhow this is 0 plus half, and let's take here half G, and here t square. This one we have got one equation. Okay, now after that what I will do here, I will use the again equation where to where. Now I am going to use from A to C. Okay, so what will happen that here, when I will use the equation A to C, same equation, same this equation I am going to use it. Okay, so what will happen that here, so now you think A to C how much? 100 plus 100, because downward, 100 equal to 0 plus half G. How much time A to C? 0 to t, that means t square, is it? Now what will happen that, students, here this is equation 1 and this is equation 2. What we need? We need this one here, gravity value here. Okay, so what we can write here, just remember that one more thing here. Now this is t minus half, no? 0 to t minus half, where 0 to t minus half is missed here. Think 0 to t minus half, where it missed here, students? 81, that time here it is the t minus half. Okay, just let me correct it here. No? Mistake happened here. G, it is how much here? T minus half square. Okay, t minus half square. Now we have to get the value of what? We have to get the value of the G. Okay, so what we can do here? So these two equations we have, and we need the value of G. Anyhow we have to eliminate the t. Okay, so let's see here, how can we get it? Let's divide the equation. Let's see here, 81 by 100 is equal to half G, anyhow cancelled. It will become, yes, here t minus half whole square by t square. We'll get the value of t, we'll put here, and we'll get the value of G also. Okay, that is the easiest possible way. So what will happen here? Can you see the students here? 81 by 100, take the square root this side, so it will become here what? 9 by 10 is equal to, see the students here, t minus half by t, correct na? Because square and square is there. Then what will happen that here, see, t by t means 1 minus 1 by 2t, is it? Now after that what will happen that here, can you see here, it will become here 1 by 2t is equal to 1 by 2t is equal to 1 minus 9 by 10, that means 1 by 10. So we can tell 2t equal to 10, and hence t is coming here 5. What t is coming? T is coming 5 seconds, is it? Total time 5 seconds. Now what we want? We want the value of G. So again we'll use from the equation 2, easy for this. Now, so what is the value of the G, students? Kindly see here, this G will become here 100 into 2, 200 by t square, 200 by t square. So see here, 200 by 25. No? 5 square means 25. So 200 by 25, how much here? 8 meter per second square. Which option is correct? Not option. An 80 kind of question. So what will come here? 8. It will come here 8 meter per second square. No? Anyhow, definitely this is not the Earth. Some other planet is there, and we are getting here how much here? 8. Is it? Great. Now students, let's see the next question. Very easy question. JEE 2023 question is there. Let's see here. A ball is thrown vertically upward with an initial velocity of 150 meter per second. Okay. The ratio of velocity after 3 seconds and 5 seconds is x plus 1 by x. The value of x is how much here? Okay. So here remember that here one thing here, we are throwing with how much velocity? 150 meter per second. Now, so let's take here. This is here we are throwing. Now, so you how much is given here? Anyhow upward positive 150 meter per second. This is point A, and let's take here at the highest point, point B. Then it will go up and here B, and again it will come back here and it will hit with how much here? 150 meter per second. And let's take here, this is A dash. Is it? So let's see here the time taken to move from A to B, how much here? Okay, so time taken to move from A to B is called what? Time of ascent, is it? So time of ascent formula, what I have told you, U by G. Now, because we have to identify now when we are throwing with a 150 meter per second, then where 3 seconds will fall, where 5 seconds will fall, maybe 3 seconds while during up, 5 seconds maybe while during down, is it? So we have to identify it. So for that we have to calculate time of descent from A to B, is it? So U how much here? 150, G value 10. So how much coming here? 15 seconds. So we can understand very well 3 seconds and 5 seconds will reach when the ball is going only up, is it? Because time of ascent is 15, descent also 15, time of flight is 30, is it? So let's see here what is happening. Let's take here A, B, let's take here I have taken somewhere point C. Okay, here time is t equal to 3 seconds, and let's take here D, and here time how much here? 5 seconds here, is it? And anyhow at point B, time how much here? You know, time of ascent is 15 seconds. And anyhow the ball is going in upward direction, then which sign convention will use here? Anyhow upward plus downward minus, is it? So next one, if we do here, we apply the equation of motion from where to where? From A to C and A to D. So A to C, velocity, let's take here velocity is VC, let's take for example, and here velocity is VD, is it? So we have to take the ratio actually because they are telling the ratio. So VC by VD, how much here? VC, anyhow V equal to U plus 80, so U is 150 plus acceleration value, anyhow downward minus, and how much here? Minus 10. Now you are intelligent, you can understand very well now. Minus 10 meter per second. So 150 plus minus 10 into how much time is there? 3. I'm using the formula V equal to U plus 80. Okay, here also let's say here 150 plus minus 10 into how much time here? 5 seconds time are there now because A to D, is it? So let's simplify this here. It will come here 150 minus 30 by 150 minus 50. So what it will come? 150 minus 30 means 120 by 150 minus 50 means 100. And if we will cancel also by 20 and all, so it will come here 25 is 100, 26 is 120. So what is coming here? 6 by 5. But remember that here this 6 by 5 we have to compare with which one? X plus 1 by x. So when you are comparing with the x plus 1 by x, even you can, by seeing itself, you can see very well the value of x, how much here? The value of x is coming here 5. Okay. So the value of x 5, the correct option is here, option B is the answer. Is it? Great. See in how much beautiful way we are solving the motion under gravity based questions. Now students, the next question is what? Let's see here. A balloon was moving upwards with a uniform velocity of 10 meter per second. An object of finite mass is dropped from the balloon when it was at a height of 75 meter from the ground level. Okay, so anyhow the height is given 75 meter from the ground level, velocity is given 10 meter per second. Now the height of the balloon from the ground, when object strikes the ground was around how much here? Okay, so let's see here students. So let's take here from here. Now this balloon is there, now balloon is going, and when the balloon is here, now balloon is having some velocity. What is the velocity of the balloon? The velocity of the balloon is the 10 meter per second. How much here, students? 10 meter per second. Now from the balloon, what is happening that here? Some stone, let's take here, stone is dropped here. From here, stone. So the moment stone will be dropped from the balloon, the stone will get the velocity of the balloon. Okay. So what is the velocity of the stone here? This is the stone, and velocity of the stone anyhow. Again, I'm writing yes here. This is the velocity of the stone. It will come here. U equal to 10 meter per second square. Okay. And what will happen that here? It will go up, and then it will fall, and it will reach the ground. Okay. It will reach the ground. Let's take here with velocity v. Now, and what is the height? Height of the balloon. Height of the balloon is given here 75 meter. Is it? See, it is given here 75 meter. Okay. Now remember that here. Let's take here, for example, stone S. No? This is the initial point S, and let's take here this point I have taken here T. Okay. So what I am going to do here, I am going to use the equation of motion from S to T. Which equation of motion? Actually, we need the time. Okay. And this 75 height also given. So I am going to use here S equal to ut plus half at square. Okay. This I am going to use it, because no other choice is left. So remember that here anyhow, upward plus, downward minus. This is the sign convention. A value will be anyhow minus value. How much here? Minus. They have given 10. So minus 10 meter per second square. Okay. So just think this S will be plus 75 minus 75. Initial point, final point, like this here, like this. Okay. So this will come here minus 75. So see here, students, this minus 75 is equal to how much initial velocity? 10 plus 10 or minus 10? Plus 10. 10t. Nah? And this is the anyhow the time of a flight we can tell. Okay, the time taken, let's take t. Here time is how much here? Let's take here time is t equal to 0, and here time is t equal to t. Is it? So 10t plus 1 by 2 minus 10 into t square. We need this time. Nah? Then only we can use it further. Okay, so see here. It will become here, see, minus 75 is equal to 10t. And here it will come here minus 5t square. Okay. Can we divide both the sides by 5? 5? Okay. We can divide both the sides by 5. So it will become here 75 by 5 means minus 15 equal to 2t minus t square. Now see, quadratic is forming. Okay. So we have to solve now this quadratic, students. So see here, it will come here t square minus 2t, t square minus 2t minus 15 equal to 0. Okay. And when we are subtracting, it should come 2. So 5 into 3, 5 minus 3. Is it? So see, it will come here, see, t square minus 5t plus 3t minus 15 equal to 0. Kindly simplify this here. So take the t common, it is coming t minus 5 plus 3 common, t minus 5 equal to 0. Then what will come here, students? See, t minus 5 in one bracket, t plus 3 in another bracket, 0. So from here you are getting the two roots. One, when the t minus 5 equal to 0, so t is coming here 5 seconds. When t plus 3 equal to 0, it will come t equal to minus 3 seconds. Which one is the possible? 5 seconds is possible. That means the time taken by stone to reach the ground, how much? 5 seconds. Is it? In that 5 seconds, what will happen? The balloon will go upward direction. Is it? So in that situation, if I write here how much height the balloon will go up, so if I write here, kindly see here the height of the balloon. Here I am writing here. So height of the balloon will become how much here? This is the 75 going up plus with how much velocity? 10. 10. Nah? 75 is there. The stone is going down. Balloon is keep on going up. How much time here? How much time? Let's take here. This is 75. Here t equal to 0, and let's take here at t equal to 5. Let's take balloon is this somewhere here at t equal to 5. Stone is here. Balloon is up. Total how much here? 75 plus this distance here. Nah? So initial velocity 10. Time how much here? 5. So 10 into 5, 50. So 75 plus 50 how much? 75 plus 50, 125 meter. That means from the ground, how much height of the balloon? 125 meter. Now, first we have to see the stone. We have to get the time. That time we have to use for the balloon. Okay, great. Now, students, let's see this question here. The question asked in a JEE 2024. The question is here. A body falling under gravity covers 2 points A and B separated by 80 meter in 2 seconds. the distance of upper point A from the starting point is how much. Okay, so let's take for example, here let's take here somewhere my starting point is there S, okay, and here velocity is 0. When it will fall here, let's take here somewhere in middle A will come, and here let's take here B will come now. And anyhow, this one how much is given here? A to B. A to B, how much distance is given here? 80 meter. How much is the distance here? 80 meter. Okay, and the time how much here? Let's take for example, if I am writing a, let's take here for example, here the t equal to 0. So let's take here t equal to t, and here what will come here? How many times it is taking? How much time taking? 2 seconds. So we can write here t equal to t plus 2. Again I am telling this is the time indication. Here t equal to 0, here t equal to t, here t equal to t plus 2. Even if you are going here, we can write here t equal to time of descent. Is it? Anyhow. So now students, what we are going to do here? What we have to calculate? The distance of upper point A from the starting point. This we want. No, this we want. This is h, let's take. Okay. Sign convention. Anyhow, going in downward direction. This plus, upward minus. A will be anyhow, how much here? Plus 10. Plus 10 meter per second square. So what I am going to do here, students, remember that here. First I am going to use the equation of motion. Time is mentioned now. So we can use here, see here. S equal to ut plus half at square. Okay. This equation, students, I am going to use from where to where? A to B. A to B. Okay. So what will happen that here? Downward is the plus. No? Downward is plus. So 80 is equal to u, here. Initial velocity here. Now let's take here initial velocity here VA. How much velocity? VA, let's take here. So VA, and the time taken here to here, how much time taken? 2 seconds. So VA into 2 plus half, A value anyhow plus 10 into 2 square here. Is it? Because time is the 2 seconds. That means students, we can write here, see, 80 equal to 2 VA plus 2 square means 4 by 2 means 2, so 2 into 10, 20. Is it? So what this will come here? VA will come here. If I write here 80 minus 20 by 2. So 80 minus 20 means 60 by 2. That means 30 meter per second square. How much coming? 30 meter per second. VA we have got 30 meter per second. Okay. Now again, what we want? We want the value of h. Okay. So now I am going to use the equation of motion. Here time is not mentioned. So v square equal to u square plus 2as. Where to where? I am going to use from h to a. S is the initial point, A is the final point. Okay. So final point, how much velocity is there? VA. You can see very well the 30 square. 30 square is equal to initial velocity 0 square plus 2 into 10 into h. Okay. So what h will come here, students? Kindly see here. It will come here 30 square. That means 30 into 30 by 2 into 10, 20. Is it? So what this will come here, students? Kindly see here. This 0 cancel. This will come 15 times. 15 into 3, 45 meter. Now kindly check out very well. 0 cancel. 15 into 3, how much coming? 45 meter. Okay. So the starting point and A, this distance, how much here? 45 meter. Is it? Great. Okay. See how much beautiful way we are solving all this. Now students, let's see this question. Somewhat little bit conceptual question. The question is, if a ball is thrown vertically upwards with the speed u, the distance covered during the last t second of its ascent is. Very, very important. Now, so anyhow, see here. Here we are throwing, symmetry we have to use it. Here now we are throwing with velocity u. Now, and let's take here time is t equal to 0. Now, and here what is this? Time of ascent. Now, somewhere at point C, and here at point B, how much time? Because t second of ascent, that means here it will be ta minus t. Getting? Ta minus t. Here velocity is 0. Then after that it will go up. And here again what will happen that here t equal to ta, because of the symmetry of the motion. When it will reach here at point B dash here, you know what will happen that t equal to ta plus t. If it is taking t second to go up, same t second it will take to come down also, same length here. Okay. And when it will reach here, let's take here point A, and when it will reach at point A dash, again it will hit the ground with the same velocity, same speed. Direction is different, magnitude will be same. Okay, so this is called the symmetry of the motion. You know one thing, what will happen that here, see, B to B dash, and here this you can write here even C to C dash also. Okay, so you know very well here, if this distance is for example, okay, let's take here this distance is h. So this distance also how much here? H. That means understand one thing from the symmetry. In t seconds, whatever it will ascend, in the same t second it will descend also. But you know what benefit will happen when instead of ascent we'll use the descent. So here I can use u equal to 0 here. Okay, so what I can use here, students, here instead of ascent we'll calculate for the descent, because both are same by the symmetry. So remember that here distance in last t second of ascent is equal to distance in first t second of descent. Okay, students, remember that here. Now, last t second of ascent and first t second of descent, same story. Okay, symmetry of the motion. Now, t second of descent calculation is very easy. Now, we can use here, see u plus half, and here formula at square, ut. Initial velocity how much here? I am using the equation of motion from c dash to b dash here. Okay, so initial velocity at c dash 0 plus half, and anyhow acceleration how much here? G, and time taken t. So what is coming here? Half gt square. In t second of first t second of descent, half gt square. So similarly in last t second of ascent also how much here? Half gt square. Which option is correct here? The correct option is here. Option B is the answer, and here we are using this condition, symmetry condition. Okay, great. Now let's see this question. The question is somewhat air resistance is involved and all. So here the question. An object of mass 5 kg is thrown vertically upwards from the ground. The air resistance produces a constant retarding force of 10 Newton throughout the motion. The ratio of time of ascent to the time of descent will be equal to how much here? Okay, so here the mass becomes very, very important because air is involved here. Okay, so remember that here, students, if I will calculate here the retardation due to air resistance here, what we are going to calculate here? Retardation. Why we are telling the retardation? Because it will always act in opposite direction of motion. Okay, so what we can write here? Retardation due to air resistance, A equal to F by M. Force 10 Newton, mass 5. So 10 by 5, what is coming here? 2 meter per second square. What is coming here, students? 2 meter per second square. Okay, this one thing is done. Now what will happen that here? Remember that here. Now whatever height the ball will go up. Now whatever height the ball will go up, same height the ball will come down also. Now h down. So what will happen that here? H up and h down will be equal. Anyhow, symmetry is there. Is it? Now what will happen that here, students, here? You know very well here. When the ball is going up, that time you know very well gravity is downward, and this one here, air resistance. Now this also downward here. Now when the ball is going up, but what will happen when the ball is going down? That time what will happen that here? You know very well. The gravity will act downward here, but air resistance will act in which direction? Upward direction here. Okay, so remember that here, if I'll use here the G effective, here G effective will be how much here? Remember that here, A plus G, because both in same direction. Here G effective how much here? Just guess, ball is coming downward, that means G minus A. Okay, remember that. Now, and you know very well, students, here, when I will use the equation of motion, let's take here, this is A, now, this is B, anyhow this is B dash, and here let's take here A dash here. Now, so you know that very well, B dash to B dash during the down time, H down. Even if you use the second equation of motion, S equal to ut plus half at square. Okay, and here in initial velocity how much here? 0. So directly we can use H down equal to half G effective into time of descent square. What will come here? Half G effective value here, see, G minus A. G is 10, A is 2, so 10 minus 2, that means 8 into TD square here. Okay, similarly, remember that here, even H up will be in a symmetrical way, same will write here, half G effective into T ascent square. And what will happen that here, you know, half, in this situation, G effective how much here? Think, G 10 downward, A also downward here, is it? So in this situation, 10 plus 2, it will become here 12, and this is the ascent square here. Okay. Now students, what will happen that here? See here, as both are equal, what we have to calculate is the ratio of time of ascent to the time of descent here. So as both are equal, we can write here h up is equal to h down here. Okay, so h up how much here? You know very well here, half into 12 ta square. So if we simplify also, 12 by 2 means 6. So here this one 6 ta square. Okay, here 8 by 2 4, that means 4 td square here. Okay, 4 td square. So I can write here, see, ta by td whole square is equal to what is coming here, 4 by 6, that means 2 by 3. When you will remove here this square, so what will come here? Ta by td equal to root 2 by root 3. So ta by td root 2 by root 3. Which option is correct here? Option B is the correct option. And you can see here the time of ascent is less compared to the time of descent because air resistance is involved. If there is no air resistance, this ratio will come how much here? 1:1. Is it? Great. Now let's see this question. Here the question is, no, JEE 2022 question is here. The question is here. A ball is released from height h if t1 and t2 be the time required to complete first half and the second half of the distance respectively. Then choose the correct relation between t1 and t2. Okay, first half t1, second half t2. Is it? So see here, this is A here, students. No, this is B, and let's take here, this is C. No, let's take total is a h. Okay, so first half means how much it will come here? H by 2. Drop means anyhow u equal to 0. Drop na u equal to 0. Okay, because diagram is very important. No? And let's take, if we talk about the time here, so let's take here time is t equal to 0. First half means t1 time, so t equal to t1. Second half t2 time, that means total time how much here? T equal to t1 plus t2. What is coming? T equal to t1 plus t2. A to B, t1 time, B to C, t2 time, total time, t1 plus t2. Is it? Now what will happen at here, students? Let's see here. I am going to use the equation of motion from A to B. Which equation? Second equation of motion. Is it? So what is here? See the students, S equal to ut plus half at square. Okay, that means what is the value of S? It will be h by 2. Why? Because downward I am taking the plus. Okay, so it will happen here. See the students, h by 2 equal to, anyhow u is 0, so half g into t1 square. Correct? Similarly, if I go for the next one, no, I am going to use from this one here, A to C. Okay, A to C here. Again, see this equation, S equal to ut plus half at square. Then what will happen at here? Think please, A to C, how much total? H, is it? So this will come here, H equal to half G, and total how much time here? T equal to 0, here total time T1 plus T2, A to C. So T1 plus T2 square. Now what we'll do here, students, here, this equation and this equation, we will just divide it here. Okay, so when we'll divide the equation, what will happen at here? See, h by 2 by h cancel, so half is equal to half g anyhow cancel, so it will come here what? T1 square by T1 plus T2 whole square. Okay, so take the square root both the sides here, students. 1 by root 2 is equal to, can you see, T1 by T1 plus T2. Now what will happen at here? See, this T1 plus T2 will become here root 2 into T1. Is it? Send T1 this side, so it will become here. What is students? This T2 equal to, just think, root 2 minus 1 into T1. Which option is correct here? Can you see the students? It will come here. The correct option is here. Option D is the answer. Is it? Asked in a JEE 2022 exam here. Is it? Great. Now students, let's come to this question, last question. Asked in a JEE 2022, but very interesting question. The question is, see, from the top of a tower, a ball is thrown vertically upward, which reaches the ground in 6 seconds. Not thrown upward. Second one, a second ball thrown vertically downward from the same position with the same speed reach the ground 1.5 seconds. Second situation. Now, a third ball released from the rest from the same location will reach the ground in how much seconds here? Okay, here we are going to get here one standard condition here. Okay, and you see here, this is height h, this is height h, this is height h. 3 situations are there: situation 1, situation 2, situation 3. Okay, now what is happening that here? Remember that here in first situation, from here the ball is thrown upward with velocity u. It will go up and it will come down here. Okay, and let's take here time how much here? Let's take a t equal to 0, and here time is t equal to t1. Okay, now the second situation, what is happening that here the ball is thrown downward direction with the same speed, okay, and let's take here t equal to 0 and time here t equal to t2. Now t equal to t2. In third situation, what is happening that here the ball at t equal to 0 is just dropped here, so u equal to 0, and let's take here the time taken is t equal to t3. Is it? Now students, what I'm going to do here, anyhow the gravity in which direction? Downward direction here, is it? And I'm taking upward plus, downward minus here. Now, so see, so many arrows, actually it is coming downward direction. I will make somewhat reverse so that the plus minus sign should be avoided. Let's take downward plus, upward minus I have taken here. Okay. Now let's see here. If we talk about the displacements anyhow in which direction? Downwards direction here. Correct? See here everywhere. See, so many arrows in downward direction. No? That's why taking downward plus is a very, very beneficial. So what I'm going to take here, in first situation, I'm going to use the equation of motion, s equal to ut plus half at square. Okay. Use here. Anyhow, in all the situations, let's take here initial point A and final point is B. Okay, initial point A, final point is B, is it? So what we can write here, velocity plus or minus? Minus upward, is it? So see here, and h value plus or minus? H, see downward here, h is plus. So see here, h equal to minus ut1 plus half, and here we can write here half gt1 square here. Now, h equal to minus ut1 plus half gt1 square. This minus is there. This minus because of this velocity upward here. If you wish, you can write here minus u, no problem, no, because upward minus. Similarly, if we talk about here the second situation, this one here, anyhow, let's take here this is point A and this is point B. Again, use the equation of motion. Which equation? This equation, s equal to ut plus half at square. What will come here? H, anyhow plus only, so h equal to now this velocity downward plus, so see here time taken t2, so ut2 plus half gt2 square here, is it? This is the equation, we have got it, is it? Now students, if we'll see here the third condition, you know what is happening. See here, s equal to ut plus half at square here. Now third situation, here the ball is just dropped here. Now anyhow this is A and this is B. Okay, so in third situation, what will write here? Anyhow h is equal to u is 0. Now so half g t3 square here, is it? So see here, we have got the three equations. Now first situation thrown upward, second situation thrown downward, third situation dropped. Now students, what we are going to do here, we are going to solve this first two equations and we are going to eliminate the value of u. Okay, so what I am going to do here, to eliminate the u, here I will multiply with the t2, here I will multiply with the t1. Okay, see what I am going to do here, see what I am going to do. So see the students here, as we know very well here, see h equal to minus ut1 plus half g t1 square. Okay, if I multiply with the t1, so what this will become here, see ht1, not t1, multiply with the t2. So see here, ht2 is equal to minus ut1 t2 plus half g t1 square into t2. Is it? We have multiplied with the t2 both the sides here. Now, second one, what is the equation? See, h equal to ut2 plus half g t2 square. Now here I will multiply with the t1. Okay, so what this will happen is here, ht1 is equal to multiply with the t1, so ut1 t2 plus half g, and here what will come here, t2 square into t1. Is it? Now students, what will happen that here, both the equations I will add it. So when I will add both the equation, this minus and plus will cancel out. No? So what this will become here, ht1 plus ht2 is equal to, kindly see here, half g, and if I take here t1 t2 common, so it will become here t1 plus t2. Is it? Now students, here this h is the common. Now t1 plus t2 is equal to half g t1 t2, and in bracket what is coming, t1 plus t2. Now can you see very well what will cancel out both the sides? T1 plus t2 is cancelled. Okay, and what is h? H we know very well here. See from here, this h value half g t3 square here. Okay, so see I will write here, see half g t3 square is equal to half g t1 t2. Both the sides, what is happening students here, this half g and half g is also cancel. That means it will come here. T3 square equal to T1 T2. That means we can write T3 equal to root T1 T2. What is coming formula? T3 equal to root T1 T2. Okay. Now let's see here. Let's see here. T1 how much is given here? 6 seconds. Now this is the T1. T2 how much is given here? Now when thrown downward here, 1.5 seconds. So 6 and 1.5. Okay. So let me write here. See, 6 into 1.5. It will come here. Root 9. Directly remember the formula. So root 9 how much is coming here? 3 seconds. See how beautifully we have just proved this formula here. So what is the correct option here? The correct option is here 3 seconds. It's an 80-based question. So answer is 3 here. Okay. So students, I hope so. This video we have discussed the number of questions of motion under gravity. We have understood very well. Keep studying. Keep growing.